students, previous class we have learned the equation of the tangent and normal to both the parametric point and the Cartesian points. So based on that concept, let us try out the problems from the textbook. These are all the examples from page number 151. Find the equation of the tangent and normal to the ellipse 9x square plus 16y square equals to 144 at the end of the lattice rectum in the first quadrant. So first of all, given ellipse is 9x square plus 16y square equals to 144. Let us convert this into x square by a square plus y square by b square equals to 1. So this implies 9x square plus 16y square by 144 equals to 1. So 9 by 144 is 16. 1 by 16. So this is x square by 16 plus y square by 9 equals to 1. Here a square equals to 16, a is equals to 4, b square equals to 9, b equals to 3. So therefore a is greater than b ellipse it is. That means the ellipse is going to be a horizontal ellipse like this. Now we want a tangent where at the end of the lattice rectum in the first quadrant. So this is a dash, length of the minor axis, b dash, length of the minor axis. This is s dash, or the foci of the ellipse. This is e comma 0. So this is the lattice rectum. The lattice rectum is a chord which is perpendicular to the major axis and passing through the focus. So this is L dash. So this we know e comma b square by a. This is e comma minus b square by a. L dash equals to. L dash is a comma minus b square by a. L is a comma b square by a. And length of the lattice rectum is 2b square by a. That's we have learned before. Now, positive end of the lattice rectum, that is first quadrant, is this. So this we no need to take into consideration. Now, so L is equals to a comma b square by a. First of all, let us find out the eccentricity E. E is equals to square root of a square minus b square by a square. So square root of a square is 16 minus b square is 9 by 16. So this is 16 minus 9 is 7 under root. So root 7 by root 16 is 4. Therefore, L equals to AE. A is 4. E value is root 7 by 4. Comma b square by a. B square is 9 by a is 4. B square by a is 4. This is 4. 4 gets cancelled. This is root 7 comma 9 by 4. Now we want equation of the tangent. What is the equation of the tangent? Equation of the tangent at px1 y1 to the ellipse s equals to 0 is s1 equals to 0. And what is s1 equals to 0? x1 by a square plus y1 by b square minus 1 is equals to 0. So this is x into x1 value is, this is x1 and this is y1. So x into x1 is root 7 by a square is 16 plus y1. Y into y1 is 9 by 4 by b square is 9 minus 1 is equals to 0. So this is root 7x by 16 plus this is 9y by 4 into this is 1 by 9 minus 1 equals to 0. So 9 gets cancelled. So the LCM is 16 root 7x plus 16 by 4 is 4. So 4 into y minus 16 by 16 equals to 0. So therefore this is our equation of the tangent. Now equation of the normal at px1 by 1 to the ellipse s equals to 0 is a square x by x1 minus b square y by y1 is equals to a square minus b square. So a square x, so x1 is root 7. So a comma b square by a, how much we get this? Root 7 comma 9 by 4. So a square is equals to 16, b square is equals to 9. These are what we got earlier. Minus b square y, b square is 9, y by y1 is 9 by 4 is equals to a square minus b square, 16 minus 9. So a square is equals to 16x. So this is 16x by root 7 minus 9y by 1 into this is 4 by 9 is equals to 16 minus 9 is 7. So this is equals to 9 gets cancelled. 16x minus 4 root 7 y by root 7 is equals to 7. So LCM is root 7 here. So 16x into 1 minus root 7 into 4 into y. So therefore the answer is 16x minus 4 root 7y is equals to 7 root 7 is the equation of the normal at the one end of the lattice rectum in the first quadrant. If a tangent to the ellipse x square by a square plus y square by b square equals to 1, where a is greater than b is given, that means the ellipse is going to be like this. This is our ellipse. And a dash, this x-axis is our major axis and this y-axis is our minor axis. Now, tangent to this ellipse meets the major axis and minor axis at M and N respectively. That means a tangent, for example, at this point, this is the tangent, for example. Let us suppose that this is a tangent. What is a tangent? A line which touches this ellipse at a unique point. So, now this tangent meets the major axis at M. This tangent meets the major axis. What is the major axis? X-axis. So this tangent meets the major axis at M and minor axis at N. So the same tangent meets the minor axis. Minor axis is y dash. So at N. So this is N. respectively, then prove that a square by cm square plus b square by cm square equals to 1. This is what we need to prove. Where C is what? C is the center of this ellipse. So if the center is at the origin, then that ellipse is said to be what? The standard form of the ellipse. Now, let P theta. So let us suppose that this is P theta. Let this be P. I'll take the parametric point. So P theta is what? A cos theta, comma B sin theta. So let P theta is equals to A cos theta, comma B sin theta. Be a point on the ellipse. Now, if this is a point, so here Cm is equals to, okay, so this is Cm and Cn, this is Cn. So to obtain the Cm and Cn, first of all, let us find out the equation of the tangent at P. So equation of the tangent at P theta to the ellipse S is equals to 0 is x cos theta by A plus y sin theta by B equals to 1. This we know. So from this, x by A by cos theta. So this is x cos theta by A. So x by A by cos theta we can write. Plus this is y by B by sin theta is equals to 1. So we got the equation of this tangent. So since this is of the form, the intercept form x by A plus y by B equals to 1. What is the feature of the intercept form of a line? So this cuts the x-axis at A by A cos theta. So this is A by cos theta. Since this point M is on the x-axis, y coordinate is 0. And this intercept form of the line cuts the y-axis at N. And what is this N? 0 comma B by sin theta. Because on y-axis x coordinate is 0. So we got M and N. So therefore what is Cm here? Cm is equals to A by cos theta. This distance. And Cn is equals to, this Cn is equals to B by sin theta. So Cm equals to A by cos theta and Cn is equals to B by sin theta. So from this, cos theta is equals to A by Cm. So from this, sin theta is equals to B by Cn. So now, from this, cos square theta is equals to, squaring on both sides, we get A square by Cm square. And sin square theta is equals to B by Cn whole square. This is B square by Cn whole square. Now, we know that sin square theta plus cos square theta equals to 1. Sin square theta plus cos square theta equals to 1. So, what is sin square theta? B square by Cn square plus cos square theta is A square by Cm square is equals to 1. That is what we need to prove. A square by Cm square plus B square by Cm square equals to 1. Find the condition for the line Lx plus My plus N equals to 0 to be a tangent to the ellipse x square by a square plus y square by b square equals to 1. Second, Lx plus my plus n equals to 0 to be a normal to the ellipse x square by a square plus y square by b square equals to 1. So let us suppose that this is our ellipse. So now this is the tangent, for example, at a point P theta. I will take the parametric point. And this line is Lx plus my plus n equals to 0. So let the line Lx plus my plus n equals to 0 be a tangent to the ellipse x square by a square plus y square by b square now equation of the tangent at the parametric point p theta, which is a cos theta comma b sin theta, is x cos theta by a plus y sin theta by b equals to 1 or minus 1 equals to 0. So at p theta, the equation of the tangent is this. But according to the problem, the same line is Lx plus my plus n equals to 0. That means, so this and this. According to the concept, this is what is this? X cos theta by a plus y sin theta by b equals to 1. This tangent. But according to the question, the same line represents Lx plus my plus n equals to 0. So both these lines represents the same line. 1 and 2 represents same lines. So comparing we get, so here x coefficient is cos theta by a, by here x coefficient is L by L. This is equals to y coefficient is sin theta by b by y coefficient is m is equals to, here constant is n, here the constant is minus 1. So minus 1 by n. From this, cos theta by a by b by c, a by bc. So cos theta by al is equals to sin theta by bm is equals to minus 1 by n. So equating first and the last one, will get cos theta by al is equals to minus 1 by n. From this, cos theta is equals to minus al by n. Similarly, sin theta is equals to minus bm by n. Sin theta equals to minus bm by n. Now, we have sin square theta plus cos square theta equals to 1. So this is sin square theta is minus bm by n whole square, b square m square by n square, plus cos theta is minus al by n. squaring on both sides. Cos square theta equals to minus al by n whole square. Square minus square is plus. So this is a square l square by n square is equals to 1. So take LCM n square, then we'll get a square l square plus b square n square is equals to 1. Therefore, a square l square plus b square n square is equals to n square. This is the condition for the line Lx plus My plus n equals to 0 to be a tangent to this ellipse. The condition for the line Lx plus My plus n equals to 0 to be a normal to the ellipse. So at this p theta, earlier this is a tangent. So this is a tangent and the line perpendicular to this tangent is this. So earlier this is the tangent. For this tangent, this is, let the line, this line Lx plus My plus n equals to 0 be a normal. Normal means, let us suppose at this point, this is the tangent. The tangent is a line which touches this ellipse at only one point. Let us suppose this is the tangent and the line which is passing through this point of contact of this line and the ellipse. This is this point of contact. The line which is passing through the point of contact and perpendicular to this tangent, that is this, is a normal. So let the line Lx plus My plus n equals to 0 be a normal at p theta, which is a cos theta, b sin theta on the ellipse x square by a square plus y square by b square equals to 1. So equation of normal at p theta is x cos theta by a is a square x by is ax by cos theta minus by sin theta is equals to a square minus b square. So from this, ax by cos theta minus by sin theta minus of a square minus b square is equals to 0. So therefore, this normal at p theta is this. But according to the question, the same line is normal. The same line is a normal. What is that line? Lx plus My plus n equals to 0. So that means 1 and 2 represents same lines. At p theta, this is the equation of the normal and that normal is this. But according to the question, the same line, the same normal is this Lx plus My plus n equals to 0. Therefore, comparing 1 and 2, we get here coefficient of x is a by cos theta by L is equals to minus, y quotient is minus b by sin theta by m is equals to constant is minus of a square minus b square by n. So this is equals to a by b by c, a by bc. So a by cos theta 1 by L. So a by L cos theta is equals to minus b by m sin theta is equals to, this is minus of a square minus b square by n. So from this, a by L cos theta, first and last I'll compare, is equals to minus of a square minus b square by n. So from this, an, so an by L into minus L into a square minus b square is our cos theta. So this is cross multiplication I have done, n into a and a. So L into minus a square minus b square, this cos theta I have brought onto that side. So similarly, so bn by m into a square minus b square is our sin theta. So if you compare these two, then we will get bn by m into a square minus b square equals to sin theta. So squaring and adding these two, because sin square theta plus cos square theta equals to 1. So this is equals to a square m square by L square into a square minus b square whole square plus b square n square by m square into a square minus b square whole square equals to 1. This is what we get. From this, n square by a square minus b square whole square. Let us take n square by a square minus b square whole square common in both of them. Then we'll get a square by l square plus b square by m square is equals to 1. This implies a square by l square plus b square by m square, and this is multiplying with this term. If you bring onto another side, this will be reversed. So this is equals to a square minus b square whole square by n square. This is the required condition. If a normal at one end of a lattice rectum of the ellipse x square by a square plus y square by b square equals to 1 passes through one end of the minor axis, then we need to show this e power 4 plus e square equals to 1, where e we know that the eccentricity. So since which kind of ellipse is not given, therefore let us take the standard form, that too a is greater than b. So let us suppose that this is our ellipse. This is our ellipse whose center is at the origin, and now this s dash or the foci, and this l dash are the ends of the lattice rectum. If a normal at one end of the lattice rectum of the ellipse. So normal, how do we draw a normal? Before drawing a normal, it is compulsory to first draw a tangent. So at this L, this is our tangent, for example. This is our tangent, and the line which is perpendicular to this tangent is normal. This is our normal. And normal at one end of the lattice rectum. So one end of the lattice rectum is L. So this S is A E comma 0. Then this is A E comma B square by A. One end of the lattice rectum. This normal at one end of this lattice rectum again passes through one end of the minor axis. So it is passing through this normal again passes through one end of the minor axis, which is B dash. B dash is 0 comma minus B. So then we need to show that this is that. So let L AE comma B square by A be one end of a lattice rectangle of the ellipse. So therefore, equation of the normal at x1 y1 to the ellipse is a square x by x1 minus b square y by y1 is equals to a square minus b square. So here x1 y1 is this, because this normal at this point x1 y1 we are finding here. So therefore x1 y1 is ae comma b square by a. This implies a square x by x1 is ae minus b square y by y1 is b square by a is equals to a square minus b square. So this is equals to this a gets cancelled, a x by e minus b square y by 1 into this is a by b square is equals to a square minus b square. So b square gets cancelled. This is ax by e minus ay. This is ay equals to a square minus b square. So this is the normal that we have got here. But according to the question, this normal is passing through one end of the minor axis. But this normal is passing through one end of the minor axis, which is b dash, which is 0 comma minus b. That means a in the place of x substitute 0 by e minus a y is minus b is equals to a square minus b square. So this is equals to 0 into this is 0 anyway, minus into minus plus ab equals to a square minus b square. So this is equals to ab is equals to a square minus, we know that b square equals to a square into 1 minus e square. A square into 1 minus e square. Since for a greater than b square equals to a square into 1 minus e square. This we know. Therefore, this b square I have replaced with a square into 1 minus e square. This is ab equals to a square minus a square into 1 a square minus into minus plus a square e square. So a square gets cancelled on both the sides. This is ab is equals to a square e square. So these two gets cancelled. So b is equals to ae square. So again, squaring on both sides, we will get b square equals to a square into e power 4. Again, b square is equals to a square into 1 minus e square is equals to a square into e power 4. So a square on both the sides gets cancelled. Therefore, we have got e power 4 minus e square. If you transpose onto another side, this is e square is equals to 1 is the condition that we need to prove. If Pn is the ordinate of a point P on the ellipse, x square by a square plus y square by b square equals to 1, and the tangent at P meets the x-axis at T, then show that Cn into Ct equals to a square. Let us suppose that this is our ellipse and this is our coordinate axis. At this point P, this is our tangent. Let us suppose that this is our ellipse, x square by a square plus y square by b square equals to 1, and the tangent at P. So this is P of theta, I will take the parametric point. So the tangent at P meet the x-axis. This is the x-axis. So this tangent meet the x-axis at T. Then show that Cn into Ct equals to a square. So C being the center of the ellipse. This is what we need to prove. I'll take the parametric point. Let P theta a cos theta, comma b sin theta be a point on the ellipse. Then the equation of the tangent at P theta to the ellipse s equals to 0 is x cos theta by a by plus y sin theta by b equals to 1. This can be written as x by a by cos theta plus this is y by b by sin theta is equals to 1. This I have written in the form of x by a plus y by b equals to 1. This is the intercept form of the line. So this intercept form of the line cuts the x-axis at a by cos theta. So this is a by cos theta comma 0. Therefore this Ct is equals to a by cos theta. So Ct here is equals to a by cos theta, and see here from P I will draw a perpendicular onto x-axis. Let n be a normal of P on the major axis, which is x-axis. Then this Cn is equals to a cos theta and this Pn is equals to b sin theta. Now what do we require to prove? Cn into Ct equals to a square, for which let us consider this. Consider Cn into Ct. Cn is equals to a cos theta and Ct is a by cos theta. So this cos theta and cos theta gets cancelled. So a into a is a square is what we are required to prove.